Welcome to our video about the Lac Operon and bacteria. The Lac Operon is a catabolic pathway that breaks down lactose in the cell. This occurs in environments where the level of glucose is low but the level of lactose is high. In this example, permease brings lactose into the cell, and B-galactosidase cuts some of the lactose, forming allolactose.
The DNA sequence is made up of the promoter for the Lac I, the promoter for the Lac Operon, the Lac O, which encodes for the operator, and the Lac Z, Y, and A, which are the three genes that code for the breakdown of lactose. The promoter, Lac O, Lac Z, Y, and A make up the lactose Lac Operon.
The Lac I gene codes for the repressor. The repressor will then bind to the operator, which forms the loop that you can see here. When there is no lactose present, the repressor will then bind to the DNA, and when there is lactose in the system, some of it will transform into allolactose, which then binds to the repressor, causing the repressor to fall off and remove itself from the DNA, no longer blocking the polymerase from transcription.
This previous process was an example of negative regulation, and this process is an example of positive regulation. When there are low levels of glucose in a cell, there are high levels of CAMP. The CAMP is able to bind to the CRP protein, which changes configuration and is bound to the DNA. This allows the RNA polymerase to bind and start transcription.
In a situation where there are high levels of glucose and high levels of lactose, there are low levels of CAMP. As a result, the CRP and a repressor will not bind, leading to a weak promoter and no transcription.
In an environment where there are high levels of glucose and low levels of lactose, there isn't cyclic AMP, and so the CRP doesn't bind. Because there are low levels of lactose as well, the repressor does bind and also inhibits transcription. Here we show that the RNA polymerase cannot transcribe.
In an environment with low glucose and low lactose, there is CAMP present in the cell, which binds to the CRP and to the DNA. There is also low lactose in the cell, which means the repressor is still bound to the DNA. When both CRP and the repressor are bound, the repressor wins out and stops the RNA polymerase from transcribing.
So here we have decided to mutate the Lac I so it's non-functional. This causes the repressor to not exist, which causes the loop to not exist, which then allows the RNA polymerase to bind, and it causes transcription to occur whenever glucose is low, regardless of how much lactose is in the environment. Thank you so much for watching. This is our video on the Lac Operon process. This is made by Marissa, Jane, Eliza, and Christine. Thank you again.